Hello and welcome to the third part of our tutorial series on GUI and app development using model-based design. In this part, we will go into the details of QML. We will start by defining the structure of a QML file, which are formally called QML documents. So let's open the QML file that we created on the previous tutorial. Open a MATLAB session, go to the directory where the file is saved, and type edit.qml and the file name, main.qml in this case. We can see that the first two lines consist of the word import, then a module name, and a version. These statements tell the QML compiler or interpreter to import the objects from the modules on the right. Modules have different versions, so we see version numbers at the rightmost position. Then the rest of the file consists of a hierarchical or nested list of QML objects. All QML documents follow this basic structure of two sections, imports and object declarations. So let's look a little deeper into the import section. QML is very extensive, therefore objects are contained within modules to keep things organized. In order to be able to use the object defined in the library, you need to import them first. You might be wondering, how do we know which libraries to import and also the correct version of the library? The easy way is to go to the Import tab on the Library section of the designer. There you can see a fairly extensive list of modules to be imported along with the correct version. The alternate way is to go to the online documentation. Qt's online documentation is among the best and most complete I have ever seen. So we will rely on it heavily throughout the tutorial, and I strongly recommend you do the same when you're developing your own projects. So let's open a browser window and do a search for QML documentation. And let's click on the first link that shows up. This happens to be the main page for the QML online help. Now, as of this recording, the latest version of EasyGUISim is 2018A, which uses Qt version 5.9 since it is a long-term support version. We can see that the help is for version 5.11, so the first thing we need to do is to change the help version to 5.9. Although there is probably very little difference between the versions, it's better to be safe. We are going to cover the most important information on this page, but you're more than welcome to browse and learn for yourself. The reference section of this help is the one that is most relevant to us, and we will continue to come back to it frequently during our tutorial. So let's scroll down to the reference section on the left and click on all QML types. Here we see a list of all the object types we can use on this version of QML. This is very important information, so we will bookmark this page. We can see that the list is quite extensive, but at the top of the page we can see that there is a link to all the available modules. If we click on that link, we see a more manageable list of modules. Let's say we wanted to add GPS capability to our project, so we look into available module list to see if there's anything that looks promising. We see a Qt positioning module, so let's click on it. I happen to know that this is exactly the module that we need for GPS access, so let's copy the import statement and paste it into our project. We keep scrolling down and see that there is a position source object type, which I also happen to know that is the one that we need for our purpose. We click on that position source and see that there is a lot of information about this type. For now, we will just copy the piece of sample code on this page and paste it on our project. We see that the editor highlights the text as in other objects on the file. So if we save the file, and run our project, we see that it runs with no errors. If we remove the import statement, we can see that the object type is now black and underlined in red to let us know that there is a problem. If we save the file and run it again, we see that we get an error. This is because our interpreter doesn't know the position source type because we didn't import the right module. Let's go back to the editor and delete the changes that we just made. Now we'll spend some time on the second and most important part of the document, the objects. In QML, as in other object-oriented programming languages, objects are instances of abstract entities that combine a set of attributes such as variables or functions. These abstract entities are known as object types in QML or classes in many other languages. In QML, an object type can have properties, signals, and methods. If you don't quite grasp the concept, don't worry. Objects are difficult to explain conceptually, but they are easy to understand in practice. So let's look at our document to clarify. We see that the first object on our document is a window object. The entry QML document always needs to have a window as the root object, otherwise other objects cannot be rendered. The next lines we see define the window properties. Properties in a QML document have a name-value pair that defines its default behavior, and the values of the properties affect the state of an object. For example, the value of the visible property of the window object defines whether the window is visible or not. This property is false by default, so we need to change it to true in our instance to be able to see the window. This has actually been an issue for me many times where my GUI doesn't work and I can't figure out why. I keep running my simulation and the main window never shows up. After the window object properties, we see some additional objects with their respective properties. All these objects are graphical objects. They are placed at a given x and y coordinate on the window and have a width and a length. Not all objects have these characteristics. For example, the position source GPS object doesn't have a visual component. Additionally to visual and non-visual objects, QML also have some objects that are brought directly from JavaScript. For example, objects such as string and bool, which are going to be used all the time, and objects like date and JSON, which are useful on very particular applications. We have seen that objects in QML are arranged hierarchically. Now, it is very important to differentiate between hierarchy and inheritance. Inheritance in an object-oriented language is when a class, which are known as object types in QML, acquires the attribute of another type and expands them. If we look at our document, we can see that there is an object of the type animated image. Let's go to the QML types reference and check out the documentation for this type. We see that this object type inherits attributes from the image object type. If we look at the properties, most of them have to do with the image animation. If we click on List of all members, including inherited members, we can see that there are several attributes from the image type that are also available to the animated image type. For example, the mirror property, which can be used to invert an image horizontally. In other words, an animated image is a type of image with unique characteristics. Just like a mammal is a type of animal with some unique characteristics, and a dog is a type of mammal with some unique characteristics, and a chihuahua is, well, you get the point. If we scroll a bit further down, we can see that animated image also has attributes from the item object type. If we click on the item link, we see that it also inherits from the Qt object type. If we click on the Qt object link, we see that it does not inherit from any other type. Qt object is the most basic object type in QML. It implements the foundation of the entire object framework, but it only has one property, object name. We will talk about object name in a few moments, but for now let's go back to our browser to the item object type. Item is the basic type for all visual object types, but it doesn't really have a visual component. Just all the elements necessary to build one. It is very important to mention that all non-visual objects need a visual parent. Therefore, the position source object we added earlier would not have worked as we had it. This has caused me a lot of grief while working on projects, so keep this in mind when you're working on yours. My solution is to contain all non-visual objects under an item object on the root window. We will see this on some examples later. Before we go deeper into QML objects, let's look into the more basic QML types and how we work with them from Simulink. In the EGS workflow, we interface with 6 QML types: Boolean, integer, double, QString, QURL, and QColor. It is very important that you understand how to work with these basic types, so we'll take some time to look at them in more detail. Let's go open our QML type bookmark and go to the basic types. We see that there is a fairly extensive list and that many of them look different to the types I just mentioned. So let's go through them to explain how to work with these types. First, let's take a look at the supported types. Here we have native types and string types. Bool is a Boolean type that can have only 2 values, true or false. This type is supported natively in Simulink. Int is short for integer and is supported as a signed 32-bit integer or int32 in Simulink. Enumerations are names given to integers to make them more readable by humans. EGS converts them to the corresponding number, so they are treated as int32 in Simulink. This does require you to know what the number represents, so we lose the convenience of the readability, but usually this is not a big problem. Double and real are equivalent in QML, and they are natively supported from Simulink as double. Next, we look at the supported string types. If you're unfamiliar with the ASCII standard, I encourage you to do a search. ASCII is spelled ASCII. Keep in mind that ASCII strings are always terminated by a null character represented by the number 0. There are 3 basic string types in QML: string, URL, and color. EGS uses the C++ counterparts of these types, so they are called QString, QURL, and QColor in Simulink. We will go into more details on how to work with strings on the Simulink part of this tutorial. URL and color are special types of strings, so let's go over the details. A URL refers to a resource location, for example, the path to an image file. QML does not differentiate between local or remote resources, so all URLs are treated equally. QML doesn't care if the file is located on the host PC or on a remote server, as long as you provide it with the correct address to find it. In QML, colors can be defined in 2 different ways: SVG color names or hexadecimal RGB values. We will go over some examples using colors later on, but you can do searches for both of these terms if you're unfamiliar with them. There are some types that are not supported by EGS, but we can use them by using workarounds. The date is one of these types. Date is actually a JavaScript type that QML inherits and expands. This type has a method called getTime that returns an integer number representing the number of milliseconds since the midnight of January 1, 1970. Similarly, the setTime method takes an integer number representing the milliseconds since that same date. We can use these methods to work with dates from Simulink. Keep in mind that this number might be bigger than the biggest int32 value, so you might have to make some adjustments. Refer to the weather app example to see how to interact with the date type from Simulink. QML has group types which are created for convenience. These types join related values together to make them easier to define. For example, the coordinate type contains a latitude and longitude value to define a point on the Earth's surface. We will explore how to interact with group types later on this tutorial. There are some types that are not supported in EGS and for which we do not have workarounds. So let's go over them briefly to explain what they are and how they work. The var type can handle and contain any other property types in QML. It is not used by default in any QML object property and is there as a convenience to the programmer. It is not supported in EGS, so do not use it for properties you need to access from Simulink. Variable is simply an obsolete type name for var. A list in QML can be thought of as an array of objects. There is no support for these types in EGS, so any runtime changes to lists have to be handled directly in QML. GeoPath and GeoShape are composed of lists of coordinates, so there is no support for them either. There are 3 matrix types in QML: matrix 4x4, vector 2D, and vector 3D. They are very basic and somewhat difficult to work with, so we recommend doing any matrix calculation and manipulation on Simulink instead of QML whenever possible. Finally, point, quaternion, and size are not supported, but they do not seem to be used in any QML object type and they do not seem to have any properties to interact with. Now that we know the basic QML types, let's see how they are used in QML properties. Each object type has a number of different properties, and these properties define the object's instance characteristics. For example, they define the color, position, and size of a rectangle, which affects how the rectangle looks on the screen. When you add an object to a QML document, all property values are set to the object type's defaults. In order to change this, you need to add a property and property value pair to the object's definition. You can do this one of 2 ways, one by using the text editor, the other one by using the designer. Let's go back to our QML file to add a new property value pair. In the editor, we simply navigate to the object, hit enter to open a new line, and type our property and value. Let's change the color of our test object to green. Let's see how it looks on the designer. And then from the co-simulator. We can also change a select set of properties from our objects using the designer. Let's go back to the designer and reset the color. The circles next to the properties have a menu that includes a reset option along with property binding and alias functionality, which we will discuss later. Now, when we go back to the editor, we see that the color property has disappeared because we reset it to the default value. Let's go back to the designer and try to use the color picker. You can see how it affects the text color. Additionally, you can change the transparency, but only from fully transparent to fully visible. In the ideal workflow, we would use only the designer to build user interfaces and Simulink Stateflow to do our control algorithms. Then we would have a completely graphical development methodology. Unfortunately, this is not yet possible, so you should be familiar with the QML editor and the QML syntax. On the other hand, QML is extremely simple to edit, especially when you're not using it much for algorithm development. Okay, we are now going to look at two very important properties in our workflow, the ID property and the object name property. These two properties allow us to reference objects. The ID property allows us to reference an object from other objects inside a QML document, and the object name allows EGS to reference an object from Simulink. The usefulness of the ID property will become evident when we discuss property bindings in just a few moments, but for now, it is enough to know that the property exists. On the other hand, we use the object name property to identify an object from Simulink. EasyGUISim requires object names to be unique in order to correctly identify each object and will throw an error if the object name used in a block is repeated. The QML designer has a field where you can enter the object's name or you can enter it directly from the editor. Now let's see what property bindings are and why they are so useful. QML allows properties to be bound together so that one property can change in response to another. For example, the height and width of an image or text field can change proportionally to the height and width of the window. Let's try this on our example. Let's go to the designer. Now let's say that we want to make the font size of the text object to be 1/3 of the window size. Let's go to the font size property of the text object and let's change the units to pixels so that it is equivalent to the window unit. Let's click on the circle next to the font size and click on set binding and type main window dot height divided by 3. We access object property values by using the object's ID and the property name joined by a dot. Now let's save it and see the result on the code simulation. We can see that the bigger our window gets, the bigger our text is. This is an extreme feature to make your user interfaces look good on different screen sizes and resolutions, and you will see that we use it extensively in our examples. You probably noticed that the text is wider than the screen a lot of the time, so let's try to prevent that. Let's set the font size to be 1/6 of the window width. Now let's try the simulation again. It looks much better, but part of the text still disappears when the window width is large and the window height is small. We can use expressions in bindings, so let's try to use the min function. QML includes the JavaScript math object just like it includes the date object. So we can use the min method provided by this object. We type the expression, and try the simulation. And we can see how nice and fluid the text looks now. You can do all kinds of expressions in bindings, and I encourage you to play with it. The ternary operator is particularly useful for binding. You can think of the ternary operator as a one-line if statement. The ternary operator has three parts divided by a question mark and a colon. To the left of the question mark, there has to be an operation that returns a true or false Boolean value. To the right of the question mark, there are two expressions separated by a colon that return two values of any type. The ternary operator will return the value to the left of the colon if the Boolean expression is true, and the value to the right of the colon if the Boolean expression is false. Now let's try it on our simulation. We see that the behavior is the same as before. In this particular case, it is simpler to use the min function, but there are many other cases where the ternary operator is very useful. QML allows us to define and add custom properties to any object. These properties can be used for binding and can be binded to other properties. They are useful in a number of situations that we will see later on, so let's see how we can create and use these custom properties. From the designer, we make sure that we have the text object selected. Then we go to the Connections section below the navigator and click on the Properties tab. We click on the plus sign and change the property name to font pixel size, the type to int, and the value to 20. I encourage you to use defined types instead of the var type to avoid confusions and because the var type is not accessible from Simulink. We can go back to the editor and see the effect. Of course, you can do this directly from here too. Note that as it is right now, this property has no effects on any objects. This property is now accessible from Simulink and has a corresponding signal that is emitted when it changes. Note that as it is right now, this property has no effect on any objects. Earlier, I mentioned that font was a group property type, and I told you that there were workarounds to be able to use these unsupported types. The custom property that we just created can be used to access the value of the font group from Simulink. Let's go back to the font size and bind the property to our custom property. We can see that now we can change the value of the custom property and the font size changes. This allows us to interact with this value from Simulink. There is one more type of custom property that we need to go over, and it is called a property alias. Let's go back to the designer and click on the circle next to the pixel size property, and let's click on export as property alias. Nothing seems to happen, but if we go back to the editor, we can see that a line was added to the root window object. A property alias is a duplicate of a property that is completely bound to the original. Changing an alias is the same as changing the original property. We will see later how this is used when we talk about components. Finally, before moving on to signals, I wanted to discuss the positioning properties available on the QML designer. Let's select the animated image on our project and let's go to the Layout tab on the Properties section. On this tab, we can set anchor properties for any visible object type. Anchors is a group property that helps position the objects on the screen. You can anchor the sides and centers of an object to the sides and centers of other objects. Let's anchor the top of the image to the bottom of the text object just for fun. You see that the image doesn't change because the margin was adjusted so that it didn't move. This is the default behavior of the QML designer. So let's reset the margins and you can see the effects on the animated image. The third tab is the Advanced tab, and here you can set other positioning properties. The first property defines the origin of the scaling and rotation properties just below. These are pretty intuitive, but let's play with them a little bit so that you can see their effect. The Z property helps define the order in which the images are rendered on the screen. If you have been paying very close attention, you may have realized that the animated image is drawn on top of the text and that we can see the text only because the image is semi-transparent. If we make the image solid, then the text disappears. But if we change the Z property of the object to 1, we can see that the text is now on top. Objects in QML are drawn from top to bottom, so we can have the same effect by moving the animated image object above the text object on the hierarchy. The last three properties are relatively advanced and are often used, so I leave them up to you as an optional self-study assignment. Their information is on the documentation for the item object type. The next attribute we are going to explore are signals. Signals are equivalent to events in Simulink, and they are an indication that something has happened. Signals can be emitted when a mouse area object receives a mouse event such as a click or touch, or when a communication object receives new data, or when a GPS object gets a new position. In fact, a signal is emitted for any property change on any object. Signals can only be created from the editor, so let's create a signal called mySignal on the mouse area object. Signals can be triggered from functions, which are called methods in QML, or from signal handlers. All signals in an object have a corresponding signal handler. Its name is the capitalized signal name prepended by on. For example, in the case of our signal, the handler name would be onMySignal. Let's create an empty signal handler as an example. Signals can have arguments. For example, the click event on the mouse area type has an argument of the type mouseEvent. MouseEvent is a group type that contains information about the click event, such as the X and Y position of the click. Unfortunately, we are not able to get events with arguments in Simulink, so we have to work around the limitation if we want to use the values from an argument. In the case of the X and Y position, this would be simple since mouse area already has the X and Y positions as properties. Therefore, we just need to read these properties in Simulink when we get a mouse event. There are other properties for mouse events, for example modifiers, that are not part of the mouse area properties. But you can probably recall that we can create custom properties on any object, and we can use that to work around this issue. So let's create an integer property called last key modifiers with an initial value of 0. Then let's rename our signal to be myMouseSignal. And let's give the mouse area object an ID of mouse area. Now let's create the onClick signal handler that will assign the modifier's value from the mouse event to the property we just created. The mouse event name is mouse. We assign the value, and finally we emit the signal myMouseSignal. Now we can simply read the last key modifier property whenever we get the myMouseSignal. We will see how this works later when we talk about Simulink. The important thing to keep in mind is that you can work around some of the limitations of signal argument. This does require a bit of traditional text-based programming, but nothing too complicated as you have seen. Our goal is to limit the need for text-based programming as much as possible. We can now move on to the last QML object attribute, methods. Methods are simply functions that perform an action when they are called. For example, the play method of the audio object plays the file specified on the source property. We have already seen signal handlers, which are a special kind of method. Additionally, we can create custom methods as we have done with both properties and signals. The syntax to create a method is the function keyword, followed by the function name, and parentheses. Arguments should go inside the parentheses. However, we don't handle arguments for methods in EGS, so do not use them if you're planning to call your method from Simulink. You can work around this using properties just like we did with signals. There are some good use cases on how this works on the weather app example included in the EasyGUISim installation. Now let's talk a bit about components. I mentioned components earlier when talking about property aliases. You can think of a component as a custom QML object type. Let's say that you wanted to create a custom looking button for a project and you're planning to reuse the same style of button in various places while only changing the text. Creating a component can help you do this. The easiest way to create a component is to create a new QML file, so let's see an example. Let's go to our QML editor. First, let's undo all the changes to the current file to start fresh on the Hello World example. Then let's create a QML file and save it in the EGS tutorial directory. In this case, we will save it as tutorialbutton.qml. Let's remove the window import, change the root to item, and delete all children's and properties, etc. Let's set the item to be 100 pixels wide by 50 pixels tall. Add a rectangle and cut it to fill the parent and give it a border of 1 and a radius of 2. Let's add a text and mouse area object as children to the rectangle. Let's center the text on the rectangle and anchor the mouse area to fill the rectangle. Let's name the mouse area bottom mouse area and enable hover since we want the bottom to change color when we hover over it. Now let's make bindings on the text and rectangle colors so that they invert when the mouse is over the button. We also export the text as an alias. Rename the root item as button root. Create a signal at the root item called button click, and create a connection between mouse area click signal and the button click signal. This will emit the top level signal when the mouse area is clicked. Now let's go to our main document. Delete the mouse area and add a tutorial button component. Note that we can get it directly from the designer. Let's add anchors, sizes, bindings, etc. to place it where we want it. Finally, let's add an object name since we will access the signal from Simulink. Let's run our simulation, but first let's change the mouse area signal since it doesn't exist anymore and we would get an error if we try to run it. Let's instead use the button signal. We see that the sizes are not quite correct, but we get the behavior that we wanted. You can try doing property bindings on the width and height button as a practice if you like. Since this is a component, we could reuse this button anywhere on our project if we chose to do so. Finally, I wanted to mention that components need to be on the same directory as your main file so that QML can find them. Components are a useful weapon on the QML arsenal, and I hope you use them frequently. We are almost done on all the subjects I wanted to cover on QML, but there is one last thing I wanted to talk about before finalizing: the list model object type. This is a special type that works in conjunction with other types, for example, the list view type. The concepts involved are somewhat hard to explain, so going through a concrete example is probably the best way to accomplish this. Let's create a new project called list view example. And let's open the main QML file and delete all the children objects. Add a list view object from the library. Let's go back to the editor and let's look at the properties. We can see that we have some positional properties. Then we see two interesting properties. First, we see the model property, which value is a list model object with 4 list element children. Each list element object has a name and a color property. Properties for list elements are known as roles. Then after that, we have a delegate property whose value is a QML component. Now on the component, we see that the color of the rectangle and the text of the text object are not values, but rather roles from the list element objects above. The list view object follows Qt's model view paradigm. In this paradigm, the data is defined by a model, which in this case is the list model and list elements. And the appearance of each item on the view is defined by the delegate component. In this case, the list view is the container that manages the correct display of the items. Let's add one more item to the list model and see what happens. See that when we go to the designer, there is one more element added to the list view. List model can be used with other view types, such as grid view and path view. There are other types of model, but list view is the most common and it is supported by EGS, so we can interact with it from Simulink. I encourage you to go check out the documentation for the different views and models. Okay, we are now done with everything I wanted to talk about concerning QML, so we can move on to Simulink for the next part of this tutorial. I promise you it's going to be much shorter.